Hello everyone, and welcome. Today, we're going to demystify a feature in IR spectroscopy that can sometimes cause confusion, the overtone. You may have seen a small, weak peak on a spectrum and wondered what it was, especially if it didn't seem to match a major functional group. Well, it might have been an overtone. To understand this concept, let's start with a simple analogy. Imagine plucking a guitar string. You hear one main, loud note, which we call the fundamental frequency. However, if you listen closely, you can also hear fainter, higher-pitched notes. These are the overtones, or harmonics. Chemical bonds in a molecule behave in a similar way. They vibrate at specific frequencies when they absorb infrared light. The most common vibration is when a bond absorbs just enough energy to go from its lowest energy level, the ground state, to the first excited vibrational state. This is called the fundamental transition, and it produces the large, intense absorption band we typically use to identify functional groups. An overtone occurs when a bond absorbs enough energy to make a bigger jump, skipping the first excited state and going directly to the second or even third excited state. This requires approximately twice, for the first overtone, or 3 times, for the second overtone, the energy of the fundamental transition. Because frequency is proportional to energy, this means the overtone peak will appear at roughly double or triple the wave number of its fundamental peak. For instance, a strong carbonyl, C equals O, stretch often appears around 1715 cm superscript 1. Its first overtone would therefore appear as a very weak peak at approximately 3430 cm superscript 1, an area where you might otherwise look for OH or NH stretches. A crucial point is that overtones are always much weaker than their fundamental peaks. This is because these larger energy jumps are quantum mechanically less allowed or improbable. The probability of the transition is very low, so only a small amount of light is absorbed, resulting in a low-intensity peak. So, if you see a very weak peak at roughly twice the frequency of a very strong peak elsewhere in the spectrum, you are likely looking at an overtone. They are a natural consequence of molecular vibrations and, while usually not the main focus of analysis, knowing what they are can prevent you from misinterpreting your spectrum. I hope this clears up what an overtone is in IR spectroscopy. Thank you so much for watching. If you found this video helpful and learned something new, please consider liking the video, subscribing, or using the support links in the description below. Your support truly helps us continue to create free educational content for everyone. See you in the next video.